A very pleasant good afternoon, everyone. I'm Gurtej from Board Infinity team and welcome you all to the third session of the R programming workshop. I guess everyone is ready and very excited about this workshop. For more videos like this, please do like and subscribe to the Board Infinity channel. And if you are someone who is looking to start your career in data science, then check out our website www.boardinfinity.com, and within 24 hours our counselor team will get in touch with you. Without wasting time, I would love to welcome our coach, Mr. Karmugilan sir, who is having more than a 5-year experience in specifically data science domain. So thank you so much, sir, for connecting with us today, and virtual stage is all yours.
Hey Gurtesh, thank you so much for let me resume here. So hi guys, good evening everyone. So let's start for today rather than killing more time. So for today, rather than getting into technical before, let's understand what we have discussed so far now, and then let's get back to the topics that we wanted to go for. So just to give you an idea about what we have discussed so far in the last two workshops, just like what is data analytics and why it's so important as of today, and then we know the other factors of why it is being talking terms in recent IT world. So we have seen the justifications for it. Then we have started to discuss about data analytics lifecycle. Just to give you guys a quick recap, this is the data analytics lifecycle. So when I say a data analytics lifecycle, we talk about a data discovery, data preparation, model planning, then model building, then how do we communicate results, then how do we deploy it. The operationalized part comes into play. So with this six data analytics lifecycle factors, we just started to do the data preparation. How do we start to get the data, and then how do we handle it using R? That's the topmost agenda of our complete 5 workshops. So here, then we have discussed about the type of analytics. Just to give you guys a quick recap, type of analytics are three different analytics like descriptive, predictive, and prescriptive analytics. So we have seen examples of that. Then we have discussed about the basic functions, how to handle the help prompt of R or R Studio, and then we have seen the installations of it, and then the basic functions like setting a working directory, getting the working directory, how do we import the files, sort of basic stuff. Then we have discussed about introduction to R programming, where we just started with what are the operators available in R. And then we have seen a distinct examples for each of those. Just to give you a recap, like assignment operator, arithmetic operator, logical operator, and few other. Then we have discussed about the data types. While discussing about data types, we have discussed about what are the characteristics that it supports with R, like string, character, or integer, numeric, or factor, or the other upcoming things that we are going to discuss about. So in the last two workshops, we have discussed all of these topics. Now let's get back to what we are going to discuss today. Since last week, we were about to discuss data structures. We are going to start with data structures today. Then the agenda of actual today is basically like we are going to get the data structures done. Then we are going to discuss about data manipulation using R. Very much important and crucial place of any data analytics project, data manipulation. Of course, understanding the data is important, but at the same time, manipulating the data as per what we wanted to get into is actually even more important. To be the part of it, we are going to discuss about two different packages and then the functions associated with that. It may not be complete thing of the entire package, but we are going to discuss about the topmost and very much crucial functions that it is necessary to do any data manipulation process, which comes with dplyr and Tidyverse package. Cool. Just to give you an idea about this, then we are going to discuss about the other two parts in the upcoming two workshops. First thing to go with data visualization and then the import techniques, which we are going to discuss in the upcoming workshop. Then EDA, exploratory data analysis, the final part of the agenda of data cleaning, the entire thing, to be putting it everything together. We are going to do that in the end to end in the fifth workshop. So let's start with today, data vision, data structures. let's get into R. So perfect. So here, okay, let me share my screen. Cool. Here, what we are going to discuss with R. First thing to start with, as I mentioned, we are going to start with data structures. What is data structures? In what is that? It is something to discuss in R. Is that something that we have to go with? Let's start with that. Think about it. When we talk about data structures in general, we always mean to have different data structures in a up maybe in an overall picture. We have seen some examples like what is a structured data, what is a semi-structured data, what is an unstructured data. Is it the same thing that we're going to discuss here? No, that is up to a overall point of data highlight. But when we talk about a data structure in R, that is bit different. What I mean to say that is bit different is that the data structures are the structural component which R is actually supporting for. That is basically this one, data structures in R. Maybe let's list down what all are the data structures that we are going to discuss in this specific workshop, because we have many data structures and then like we are going to discuss about few of those and whichever is crucial enough in order to go for it. Okay. So to start with, since last week we have discussed about the data types, now it's easy to discuss about vectors, then matrices, then arrays, then we are going to discuss about lists, then we are discussing about data frames, final important one. Okay, cool. So these all are the data structures we are going to discuss in this data structures module. Okay, once we have done with data structures, we will be moving towards the other part of it. Okay, to mention it, like what is the data structures? Let's start by one. And listen guys, this is the most important thing, because without understanding what the data structures is, this vectors or any of the other data structures is something that which will make you to use the entire R component, because without understanding the data structures, we can't handle any data. So we should know what the structure that R do supports with, so that we can always plug and play. Sometimes some operation might be so much easier to perform in data frame, and some other operation will be so much easier to perform in vectors. So depends on our choice of place and then choice of data, we have to choose which data structure that we have to start with. Simple as that. That is an old picture of an idea. Okay. So to start with, we'll start with vectors now. First thing and foremost, to give you an idea, vectors is basically a collection of ordered single element. Maybe we can say like technically, if you wanted to term it, it's basically homogeneous element. Okay. But in order to mention it, let me give you a short definition about it. Vectors are basically a single, maybe homogeneous element. Okay, maybe you can say this, but at the same time, when I say, think about it, and single homogeneous, but it is always about ordered. Maybe let me rephrase it. It's basically ordered, ordered single homogeneous element. Maybe for to put it in a layman term, what does this mean? Single, maybe ordered single homogeneous element. How come this can be like defined as a data structure? Isn't that like any specific single element can't be it? Yeah, actually, any specific single element is basically a vector. If you wanted to think about it, so let's take c equal to maybe like a, maybe 5, whatever a number. Think about it here. A variable c is associated or maybe assigned with the value 5. So what's happening here? This is basically a singular element. This 5 is just a single one element specifically. Okay. So this can be called as a scalar element. Think about it. It is just one specific element. So we call it as a scalar element. Simple as that. Think about it. What if we have, rather than a single scalar element, how come we can make a scalar to a vector? Okay. We can think about like simple Excel file or a SQL table. We can call that as even a vector if we think about that way. But those have dimensions. This is where vector and data frames are actually getting differentiated with. Okay, let me put it this way. What if I just put, in order to, maybe if you talk about the syntax terminology, R works in a level like you have to give C as a syntax, and then you have to give about the next variables or the elements. 5, maybe I just give one element. I gave one second element, 2 as one element, maybe 5. Think about it here. I have 4 specific elements, 5, 1, 2, 5. Okay. But individually, everything is scalar. Putting it together, it becomes a vector. Okay. One data structure in R is basically, this is one vector. Now think about it. Then the question comes in. Is it like, it should be like just one data type? Now I believe you guys could able to differentiate when I mean data type and data structure. Data structure is what we are discussing now. Data type is what we discussed in the previous workshop. Think about it now. This is 4 different, maybe like 4 different elements with different data type. Okay, maybe it's everything is for same data type. What if I have a different data type that comes in play? Okay, now think about it. Let me execute this. Now look at it here. See, look at it here. See, in my environment, I got to see a value called C, and then it just associates those number. What if I have, as I mentioned, rather than one data type, what if I have multiple data types? Let's do an example. So I just add one more variable. Let's take a character variable ABC. Okay. Now think about it. I have one character variable. Then I have 4 integer or numeric value. Now think about it. If I execute this, maybe let me put a different variable. Let me execute this. Look at it here. As soon as I execute this, it works the same way, but look at it here carefully. In the previous element that we created, the data type remains NUM, numeric. Okay, it doesn't change to any of the other data type. But look at closely. When I created the second variable, it just created what the data type has been changed to character. Now look at that. The data type has been changed to character. What does it mean? Does it like says indirectly like it can't have multiple data types? Yeah, that is one of the technical disadvantage of vector. Vector can't be of multiple data types. It should be just one data type. Just because one element of it, look at it here, one element of it has character data type, rest everything has been converted to a character data type. Simple as this. In the environment, look at here, we got to see that every element is basically character, and then the data type becomes CHR. This is basically an idea about vector. Okay, guys, this is vectors. Simple as this, nothing much. Now think about it. What if I have one more variable? Let's take one more data type. Think about it. Last week we have discussed about one data type called logical data types. Okay, factors basically. Maybe you can call this. Now look at it here. I call it true. Okay, I execute this. Remember, true is basically a Boolean data type, either true or false. But look at it, just because one has a character data type, rest everything becomes character. Even the true becomes a character value, not a logical or a Boolean data type. What if I remove this? Okay, now look at it. I just have one Boolean result. I execute this. As soon as I execute it, look at it here. The data type is actually becoming numeric, not even Boolean or not even character. What's the idea here? Why does this happen? Look at closely. Because remember, true is associated with a numeric value called 1. What if I gave false? Maybe let me do that. Okay. Now look at it here. My A, true represented with 1 and false represented with 0. Simple as this. When you have any Boolean value, that works this way. Simple as that. This is basically vector property. If you have character value, entire vector becomes character. If you have numeric and Boolean result, Boolean data type, then it becomes numeric. Simple as that. where by default it associates with true as 1 and false as 0. Simple as this. Okay, this is vector, guys. Simple as this. Okay, with this. And how about the manipulation? How do we understand the data part about a vector? Is there any other functions that we can go with vector? Yeah, basic functions like length. Okay, see, I'm just performing a simple basic function of length. I give length function and then I pass the vector variable. Okay, vector variable, I just pass that. If I pass that, look at it here, I just get to see length is 6. Simple as this. So a vector variable do support with length function. Always keep this in mind. Your trickiest part of interview questions would be like, if I have a vector and then like this function, will it support or not? Because the function that it supports vector may not always be supporting with other data structures. Always be cautious about the functions that you use for specific data structures. Okay. Now with this, let's have a few more examples apart from this. How do we perform slicing in a way like, let's take, I have maybe 6 elements here. If I wanted to just maybe like take down few elements of it rather than all the elements, how do I perform it? Let's take, if I perform, this is the variable name is a, so I'm going with a. How do we slice it? Remember in the last session we discussed like how do we split the maybe like cut short or take down specific elements of it. Your square brackets act as your filtering idea. Maybe basically technically we call it as a slicing property. Okay, your square brackets. Then I declare the property. Let's take a specific values. Let's take 1:2. Okay. Now look at it here. Vector supports the direct slicing property. When I gave 1, I meant to mean I meant basically the index of it. So what is the index 1? The element, sorry, the element first, and 2 becomes the element 2. Simple as this. What if I mention 4? So I'm going to take 1:4. Maybe let's update the number here. 3:6. Okay, we have an element 1 to 6. 6 elements we have, so the index is 1 to 6. I choose 3 to 6. I just slice the value 2510, 2510. Simple as this. Because 1 and 0 is basically a representation of true or false, which is basically a Boolean results. Simple as this. So a vector actually do support with this specific filtering part. Okay. Now, is there a way, is there a function or something that we can create a simple vector with like a general sequencing in a way like I want like 1 2 3 4 5, or maybe like I wanted to have 1 1.5 2 2.5. Is there a way that we can create? Yeah, in order to create it, a simple seq function, sequence function. This is the base function, guys. Okay, it's nothing which associates with some package or something, but a base package, base function. Sequence of, let's take, I just choose 1 to 10. Okay, this is basically maybe like as I mentioned last week, remember guys, a question mark and then the function name will give you the property of it. Look at it here, sequence generation is the sequence function. So what are the parameters that we have to pass? So you can choose like 1 and 2. Basically like I know like the starting value, the ending value, the next one is step, how much you wanted to break with. Look at it here. Look at the documentation. Sequence starting from 2 till what number? By how do you wanted to break it? How many number of values? Let me choose, sorry, 1 to 10. I wanted to break it like 0.5. So what happens then? 1, 1.5, 2, 2.5, 3, 3.5. Simple as this. So that is how I just wanted to break it. Let's execute this. Look at it here. I got the results right now. 1, 1.5, 2, 2.5. A sequence function will just perform a simple thing. How do I store it in a vector? Simple. Let's take A is equal to, maybe I just give C of this. Simple as this. So that I just pass this into a vector and then I store it to the value A. Simple as that. Maybe let's perform it to B. Look at it now. B, a numeric value, a simple vector, 1, 1.5. The data is associated now. Maybe if you wanted to see the result, let's see the result. Exactly. So the B is basically stored by all these values. Simple as this. Simple guys, this is basically an idea in order to go with vector data structure. Okay, so let's go with the next data structure. This is basically the basic idea of vector. Having this in idea, let's go with some other vector, maybe like some other data type, next data type. Cool. What we have mentioned is matrix. So let's start with matrix. I believe many of you already have a clarity about matrix, but still, in order to give you a justification and definition, I just start with what is matrix. Okay, think about it. Vector, maybe let me list down the characteristics here one by one. Ordered single homogeneous element is basically a vector, but at the same time, only one data type is what it just has. Okay, sorry, one data type. Then it should have only one dimension. Always keep this in mind. It just has one dimension. Okay, this is basically vector. It doesn't have any dimension. It's just like one dimension. Okay, then moving to matrix. Think about it. What is the characteristics of matrix? We always feel that many of you already know about it. Just to give you an idea, matrix is basically built with row and column characteristics. Okay, row and column characteristics. Okay, characteristics. So if I say row and column characteristics, how do we call this? Row and column. You guys could have used Excel. You guys could have been used with SQL tables, which is exactly the matrix characteristics. But that's not the only characteristics. That is where it just has its own differentiation. Again, matrix can't have two data types. It just supports only one data type. If it's of two data types, it can't handle. It can't be called as a matrix. Simple as this. Okay, so this is basically matrix characteristics. To start with, let's see some example. How do we can build a matrix? So in order to build a matrix, so we have already had vector. For vector, I told you this is the syntax C. You have to give C a bracket and then give your values. That is basically can convert any values to a vector value. Simple as that. If we wanted to perform the same way, how do we create a matrix? To start with, matrix is basically a function that comes associated. Maybe look at it here. As soon as I type matrix, it just gives me the list of functions which we can go over. Look at it. As soon as I gave, matrix gives the options for what we have to go over. So first thing, we have to pass the data, whatever the data we have to give. Then number of rows and number of columns. When I mean number of rows, think about it. As I mentioned, matrix is basically built with the characteristics of rows and columns. So we have to start with rows and then we have to go give the number of columns. And technically, it's not necessary that you should be having rows and columns as an equal property. You can have higher number of rows, you can have a lower number of columns, or lower number of rows or higher number of columns. Any combination is fine. But it should pass through row and column characteristics. Simple as that. Now let's start here. Matrix. Let's build a matrix here. In order to go with the number, I go with the maybe a straightforward number. So I just choose 1 to maybe 9 elements. So that we'll start with a toy example. So I gave, this is my data. Remember guys, if I just give 1:9, that just gives me the range value of 1 to 9. Got it? Able to see the result here? 1 to 9. So if I execute 1:9. So now after the data, we have to give the number of rows and number of columns. So number of row is equal to, I just give 3. Number of column is equal to 3. Simple as this. If I execute this, look at it guys. By default, okay, by default, when we perform a simple matrix, it just goes with 1, 2, 3 in a column property. It's not a row property. Look at closely. First column has 1, 2, 3. Second column has 4, 5, 6. Third column has 7, 8, 9. By default, this is the characteristics how a matrix is built. Column level property, not a row level property. Then we might get it this way then. Okay, if that is the case, how come I can have this values row property rather than a column property? Here the column property goes with 1, 2, 3. What if I wanted to have it a row level? Simple. The next parameter is basically by rows. Okay, sorry, by rows or by columns. Okay, by row. Okay, by row is equal to true. Simple as this. So what I mean to say here, this parameter, what it does is, here by default it goes with column property, right? So what I go with, like, by row equal to true. Simple as this. So what happens is that I will be having the value row level rather than the column level. Okay, basically, like, this is basically one row, this is basically the second row, this is basically the third row, right? If this is the case, I just wanted to have by row equal to true. Okay, let me execute it. Look at it here. As soon as I execute it, earlier we haven't used by row equal to true. It's just a normal matrix. We get to see the result 1, 2, 3 happens in a column property 1, 2, 3. Now look at it. As soon as I added this property, it just makes it reverse. A row level property is associated. 1, 2, 3, 4, 5, 6, 7, 8, 9 happens in a row level. Simple as this. This is basically creating a simple matrix, guys. Let me store this value. Let's take matrix equal to this one. Now, with this, what type of data manipulation that we can do with matrix? It's very much similar to a simple vectors. So as similar to vector, you can always have a simple manipulations with a matrix. Now let's perform a simple example. Okay, so in order to do it, let's perform a simple slicing. Okay, mat is basically the matrix that we have. Then here I wanted to give the row property and column property. Remember, the slicing property in a vector is straightforward because it is one dimensional, but matrix is a two dimensional. The second property of matrix is two dimensional workspace, maybe two dimensional, maybe data structure. Simple. Okay, data structure. Okay, now look at it here. How do we subset a two dimensional data structure? Because one dimensional is straightforward. A colon becomes acts as a separator between, like, row and column, maybe like a number of values. How do this one then? It's the same property, but we have to define it dedicated for row and column. Let's do an example. One row to second row, comma, then I go with column property. I mention second row to third column, maybe second column to third column, row comma column. Okay, look at the data values now. A simple slicing, a simple subset handled with this way. Let's take like 1:2 acts as for row property. Look at it here. So 1:2 and column is 2:3. So remember, this is the matrix that we have. With this matrix, if I choose row 1 to 2, then what happens then? This 2 is basically shortlisted. Okay, row level subset, this is the one. Now on top of it, again we perform the column level property. Second column to third column. So what is the second column? It starts with 2, 3, 5, 6. We just get the 2, 3, 5, 6. Simple as this. A straightforward slicing or simple thing, we can perform it. Simple as that. So this is basic function, guys. Okay. Now we might get confused, like, okay, fine. Is this the only way to create a matrix, like using the function matrix in order to call this way? No, not necessarily. Think about it. We already have two vectors. Let's take. We already have two different vectors. Let's create a, yeah, we already have two different vectors. Okay. So let's get the equal number. Yeah, let's take A and C. Look at it in the environment, guys. We have a A variable, we have a C variable. Two has, like, one has 4 value, one has 6 value. Let's perform a simple matrix using that. Okay. So again, I'm giving, look at it closely. Matrix, the function matrix, I use it. But remember, this time we have two different variables rather than one different variable. Basically, like, we don't have a direct one data. We have two different data, right? Then how do we convert that to a matrix? Simple as this. If we have that way, what we can perform is, first thing, we can directly perform a C bind rather than using a direct matrix function. The next function, matrix, which we have seen already, like, directly pass the one data that we have. Now, if we wanted to perform it, we can perform a C bind. The other function, C bind. C bind is nothing but is basically an abbreviated function of column bind. Simple as that. Column level, we have to bind it. Simple as that. That is basically C bind. How do we perform this C bind? Simple as this. So we have A and C, right? I gave A comma C. Look at closely. C bind, column bind, A comma C. A has a different what is the number of values and C has a different number of values. If I execute this, look at it here, look at closely. We have received a warning, not an error. That's the key. It is not a warning, it is an error. Oh, sorry, it's not an error, it is just a warning. Think about it. In the last workshop, we discussed about this. Like, rather comparing with other languages, many languages generally don't support this functionality that if the length is basically mismatched, they don't actually work, they will directly produce a error for us. But what do R does that is R basically just gives us a warning and then replicates them, basically like duplicates the existing value. Look at it. Let me execute A and C. Okay, A, C. Look at it, guys. A has 512510. Okay, then we have C 5125. Okay, so basically like this 1 and 0 basically has added with 6 elements altogether, but here we have 4 elements. Now we performed a C bind. Look at the previous one. C bind, we performed A comma C. So what's happening here? A has 6 elements, C has 4 elements. Okay, if A has 6 elements, then A has 512510, but C has 5125, right? Then how come this 51 comes in? Remember the R property? It just replicates this 5 and this 1, this 5 and this one here. Simple as that. So R reproduces the first level element unless it just gives the right number of structure. Simple as that. That is an idea of having R, or basically performing a simple matrix. Simple as this. This is an idea, guys. Okay, now think about it. This becomes a matrix. I'm just giving a name, mat1. Okay, now this matrix has column name also. Unlike the other one, which has only index, which we have only index here, we just performed a C bind in order to introduce the column name A and C. So we have a column name A and C. This is the matrix 1. So we have this properties. Okay. Now with this, the basic, again, you can perform a simple basic matrix functionalities. So it will just work just like that. Okay. Then with this matrix data structure, we can go to the next matrix, maybe like data structure. Yeah, the important one. Remember which one we are discussing about? Arrays and list, right? Maybe we can discuss it together. We'll go with a list so that you can understand the differences of array. So we'll start with lists. Okay. So this data structure, how come now we have seen a connection between a vector and matrix. So vector is one dimension and it can't support 2 different data types. Matrix is a 2 dimension, but it can't support multiple data types. Now coming to list, this is where the additional exceptional part comes into play. Okay, list is basically a far more updated version of a vector. Like vector cannot have multiple data types, but list can have. Simple as that. That is the key difference between, basically, let me write it down. List can have different data type. Simple as this. This is basically the foremost important difference that comes with list and vector. So when I call this way, let's perform a simple list. Remember, as like to perform a vector, we use C. To perform a matrix, we use the function matrix. Similarly, in order to create a list, you can use the function list. List itself is a base function. So with this, let's give the values that we wanted to give. Maybe let me give 5, 7, 8, 9, comma, a simple character name, comma, true, a Boolean result, a simple binary data value. Then let me execute it. Look at closely. Maybe let me give a name for it. List1. Okay, I give a name. Now I execute this. Look at it, guys. Apart from the other things, even the mat, it just says integer with a 2 dimension. It just gives the dimension values across. But look at the list1. It just says a list of 6. It's not directly saying the data type. Why? That is the characteristics of list. List cannot have a data type as a whole. The data type itself is basically a list. Okay, the data structure itself is basically a list until unless you specify a single element of it, we can't get the data type of it. Let's see some example. Okay, how do you remember the last session? Class is the data, maybe function, in order to get the data type of it. List one, look at closely. I just execute class of list one. It just says list, got it? Which means list itself is basically classified as a data type until unless we specifyly, maybe like we manually mention or specify any specific element of it. Let's do an example. Let's check a subset, basically a squared brackets. I'm going to perform a slicing. I mention one index 1. What it means? It means 5. So I just pass list of 1, which is going to just give me the revert me with 5. If I perform a class of it, look at it, it will give still the list value, because okay, because look at closely, if I execute this list one, it still has the value of list of 5. Okay, until unless we just make it like C of list one. Okay, so that it becomes a one element rather than a list data type itself. Oh, sorry. So here, then we perform a list of 1. Okay, yeah, my bad. Cool. Look at it here. What happened? When I performed a list of 1, it just has the list data type, but it's just a sliced input of it. Okay, the result is basically a sliced level data from the list, but it doesn't, what is it, out of a list. So I just added one more bracket of it in order to make sure that element comes out of the list itself as a specific element. So I just mentioned numeric, simple as that, so that we get the classes numeric. So what if we just perform it for index 5? Let's check that. Look at it, character. For 6, it would be logical. Got it? This is basically the data type, guys. How a list associate its data type, simple as that. When you perform any one of it, of course, it will directly give the exact data type of it until unless specified manually. Got it? If not, if it's not specified, the entire thing is basically, we call it as a list data type, simple as this. So yes, guys, so this is an idea. Okay, the list data type. So as I mentioned, the difference of list is basically it can have different data types, end of the day. Okay, so with this property, let's see some more examples of list, and then how come we can perform a simple slicing or basically the other operations. Okay, so to start with, let's see, yeah, class list, right? Yeah, let me perform here list of, maybe list 1 is what we have. How do we slice it? Maybe we have seen an example, direct example, but I really like, since list has been defined this way, the question comes in, is it a 1 dimension or a 2 dimension? So list 1, I just directly give, let's take 2:5, which means I just wanted to extract or slice it, the element in between index 2 to index 5, simple as that. How do I get it? So I directly mention it, I just perform a simple slicing. I get, look at the values closely. It just gives on our overall index that maybe list we have, index 1 of the list has value 4, maybe, which is basically 2. So the second element is basically 4. According to the sliced list, that's the first element. Then the next one, 8, 9, ABC, 4, 8, 9, ABC. It just gets the same way, but remember, it's the same similar to a vector, right? But how come it just gives the difference? Because it is still a one level element within a list itself, simple as that. But when we perform it in a vector, the 4 value comes in together as a one vector, but here it just comes with the same way, but it distinctly mentions that this is basically the first element of your given list, second element of the given list, third element of the given list. So how come this makes a complete difference? Isn't that this very much similar to a, what is it, vector? Yeah, the next idea, how come it makes a difference is, list can consist or maybe created with multiple lists within. Maybe put it in a simple term, list can have multiple lists or maybe multiple data structures, to be putting it this way. Okay, when I mean it can have multiple data structures, it generally has multiple data structures. Okay, if I mentioned like multiple data structures. Is it meant to have matrix? Yeah. Let me put it this way. Rather than this one, I'm just going to pass the matrix that we have. Remember, we have a matrix MAT. I'm going to pass mat here. Look at it here. List one, list of 5489 numeric value, different data, ABC, different data type, matrix, which is itself a data structure. I pass that matrix to a list. Let me execute this. Now this is my list. And matrix index is basically 1, 2, 3, 4, 5, 6. The index is 6. Let me perform list 1 slice 6. Look at closely. It just gives me matrix sixth one has one element, and the first element is basically this one. Simple as this. Then the question comes in, why come this one comes in? It seems to be confusing. This is basically the column index and this is basically the row index. Then what is this? It means in list 6, the element of 6, it has only one element. That is the answer here. What if I have multiple elements? Let's do one more example then. Look at it here. I'm just going to perform one more example. List 2, which going to have multiple values within that. Okay, so matrix C of matrix. Look at it. I'm just going to pass a vector of matrix, comma, list 1 itself. Look at closely, guys. What I'm performing. I'm going to create a list, straightforward. But this list is going to consist of 4 numeric value, 1 character value, and 1 vector. Okay, and this vector is going to have 2 different elements. One is itself a matrix, the next one itself a list, which we already created. Let's execute this. Then let me call list 2 of, look at it here. This is basically the 6th element, right? I'm going to slice it with the 6th element. 6th element. List 2, element 6, okay? Look at it, guys, closely look at it. How many elements that this 6th one has? So it has 2 elements. Now, list first element has a list itself, basically matrix, right? So it just has matrix. The matrix value is, it has 2 dimension, row, column. First one has row, first column, value is 1. First row, second column, value is 4. 1, 4, 1, 4, okay? Then first column, third row, first column, third row, 7. Then we got 7. Similarly, now think about it. Everything is basically one matrix is splitted that way, but that's the first element. Where is the 2? Look at closely. I'm just going back down here. Maybe let me increase the. Yeah, look at it, guys. Now it might make it easy. Matrix. This is the first element. This is the 9 matrix element 1 by 1. Then look at it here. This is where the 2 starts with. Where's the 2? Yeah, first element, and then the next element. Yeah, it just starts with here. 1 of 10. Okay, the first element of it and the 10th element, which is basically my matrix. Maybe the list 1. What is list 1? List 1 is basically this one. 5, 4, 8, 9 numeric value ABC matrix. 5, 4, 8, 9 ABC and then the matrix. Simple as this. This is how the list is basically composed of. But this property may not be directly associated with vectors. Think about it. What happens then? When I pass a vector, okay, to a matrix, it just splits every individual one by one. But when I perform the same thing with list didn't collapse to the existing data type. It still resists to have the same matrix data type and then it produced the same way. But vector collapsed it. Now let's perform it this way now. I'm going to, rather than a vector, rather than a vector, I'm going to perform it with a list itself. Okay, now look at closely. A list is basically what we are creating. Within that, we have 4 numeric value, 1 character data, and then I have 1 list within itself. Okay, this list is having 1 matrix and 1 list of it. Simple as that. Let me execute this. Look at this. So list of 5, 4, 8, 9 ABC, 5 values. Then the 6th element is my list of matrix and a list. 6. I just sliced this one. Then we got one matrix, simple as this, the matrix that you have been listed with, and then the list of it. Then 5, 4, 8, 9, ABC, and then the matrix itself. Simple as this. Now look at it here. One has just one element, whatever it is. Then one of two, okay, has the other elements. So one of two has one, this is one element, this is the second element, this is the third element, fourth element, fifth element, and sixth element is a matrix itself. Simple as that. This is how a list can be created, guys. To be precise, a list can have multiple lists within that, but the other data types can't have it. Simple as that. That is basic. That's the basic difference of what is this? Data type list. Simple as this. This is the what is it? Unique characteristics of list. A list can have multiple data structures within that, where other data structures doesn't have that potential. Simple as that. Okay, so with this is basically the list, guys. With this, we can move to the next one, data frames. Final and then the foremost important one when it comes to a data analytics project, data frame. Data frames. Okay, when we call about data frames, then why do we call this is basically data frame as an important one? Okay, so run list 2. Okay, I got a question, list 2. Okay, I believe you guys got it. Does anyone have any questions for list? Because actually one important thing and parallelly like sometimes confusing. Is it clear with everyone? Like how it works and then the list one? Clear? Cool. I believe you guys parallelly been executing it on your end. So if you get any error or any of the other error or something about list, and if you couldn't able to get the results as the same as I executed here, okay, please feel free to comment it out. Let me help you guys. Okay, cool. Then so this is basically list, guys. Okay, now moving to the next one, as I mentioned, data frame, the mostly the final data structure, and then still a very much important one comparing with any of the other data structures. Why do we call data frame as a very much important one rather than other data structures? Is that in data analytics, think about it in general way, without data frames like Excel or a SQL table, we can't get our data anywhere outside. Of course, we have an unstructured data or other property, but when it comes to data analytics, even today, maybe we can talk about big data, we can talk about like unstructured text, images, video processing, image processing, sentiment analysis. Yeah, there are many, but the real time, that is the real demand actually comes into play. Even today, almost I would say 80% of organizations uses structured data. Maybe we can talk, as I mentioned, like maybe we can talk about like unstructured data, maybe we can talk about images, videos, or anything. But in reality, the idea is this one. It's basically about connecting in a way like how do we actually process the real time, because it's still structured. Then that's the purpose of the entire R or Python or Tableau or any data cleaning tool. Think about it. If the data is not structured, how come this can be directly handling it? Until unless we can't, until unless we make it a structured, maybe an unstructured data to a structured format, we can't even understand the unstructured data. So we have to come back to a structured data format in order to get any inferences. So that is a whole point or an idea of having data frames as a data structure, and as I mentioned, the foremost important one. So let's start with data frames. So what's the difference now? So now we have seen vectors, now we have seen lists, now we have seen matrix. Vector, one dimension, matrix, two dimension. Both has one data type, it can't handle two data type. List comes in order to solve that specific problem to handle multiple data types. So list can handle multiple data types, but it's one dimensional. Got it? Maybe I didn't mention it, but I really like list is a one dimensional. List is one dimensional. Okay, it is not a multiple dimension, it is one dimensional. Now the question comes in, what if I wanted to handle different properties like age, or maybe a name of the person, or maybe a status of the person as a listed different data structures and different data types comes in. Yeah, this is where data frames comes in, where we can handle multiple data types, multiple data types, sorry, multiple data types. Then the question comes in, okay, it solves one problem, multiple data types. Is it a multidimensional? It is two-dimensional, not multi, two-dimensional. Okay, two-dimensional. There are multi-dimensional data frames, but maybe data tables in SQL, but that's a different story. Okay, that's not for the topic for today, but ideally, like, for data frame, it is two-dimensional. The question comes in, if it is two-dimensional, are we talking about matrix, like rows and columns? Exactly. It do work with rows and columns property, sorry, and columns property. The question comes in, okay, fine. So it is a multiple data type and a two-dimensional, basically, which goes with rows and columns. If that is the case, is it similar to an Excel file, or is it similar to a SQL table? Exactly. Data frames are actually a ditto of an Excel file, we can call it, or basically a SQL data table, we can call it. Okay, that is basically data frames. Let's see some examples how we can actually generate data frames, and then we can just see some examples for it. Okay, so in order to discuss about a data frame, we will just see one example of what a data, how it looks actually. Data of, let's take iris. Okay, guys, I'm choosing one default data which is there in your R Studio, but when you install R or R Studio, this is basically a default data frame that you will able to see. Okay, I'm just opening this just to give you an example. Okay, okay, now, okay, let me store it to something. Let me give a name, data frame 1. I just store it to df1, then I call df1. Cool. Oh, sorry, it just saves the name. Let me directly call that. Oh, it's not loading. Okay, then I should just call the, okay, data sets. Let me, guys, if you have been already been installed, maybe you can call, right, data sets. Okay, by default, maybe if you check it in your packages list, you will able to see data sets. Okay, cd. Okay, by default, if it's not there, maybe we might have to install. Basically, like, I think I already installed in the user system. Yeah, I do have data sets. Okay, so library of data sets, then data frame 1. Perfect. So yeah, we do have received it here. Cool. Look at it here. I have iris. Okay, maybe let me call it iris. Okay, I'm just giving view. Okay, this is the function, guys. View is a function in order to view the data frame separately. Okay, rather than having it in the console section, we can have the view of the data by itself. Okay, so this is how the data looks like. The question comes in, think about it, the ideas that we have discussed about data frame. So I mentioned data frame is a multiple data types. It can handle multiple data types. Look at iris. First sepal length looks like a float value, an integer. Sepal length is the same, length is the same, petal width is the same. But look at it, species, this is basically setosa, or basically a different name comes in, versicolor or virginica, whatever. But think about it, 4 columns as flow data type, and species as the 5th column has character data type. Okay, so a data frame can handle it. Now let's check the data types. Maybe we'll finish the data type, then we'll go for rows and column property. So class of, again I'm performing the same thing, class of, we have iris now. Okay, we have iris, I just call it. Look at it here, it says the class of iris is data frame. Cool, this is what we wanted to see, we just got to see that. What it means to say is, this has a data frame data type, simple as this. The data type is data.data frame, data.frame, simple as that. Now let's execute the next part. Handles multiple data types. We have seen an example now. Let's go with two-dimensional rows and columns. Remember this one, when you look at Iris, look at it here, how it looks actually. It has number of rows. Let's see how many rows that it has. It has 150 rows and 5 columns. Okay, a simple Excel file format, 150 rows with 5 columns, simple as that. So this one is basically indexed. Okay, it's not a data that we have in the data file itself. It is an index auto-generated one. Okay, index 1 to index 150, simple as this. Index has been generated, and then the other 5 columns, as per the data, we have just able to see that rows into column property. This is basically data frames. Okay, I believe this is straightforward for you guys. Okay, so you can perform this. Now the question comes in: how do we understand this data frame? How do we process this? Is there any predefined functions or something that we can handle maybe in order to understand the data, manipulate the data? Yeah, there are many functions. To start with, and foremost used function is summary. Summary is a predefined function in order to understand the data by itself. Let me execute it so that you can see the results. By default, whenever you have this one, the summary of function, it's just going to give you, if the property is numeric, if the data type is numeric, it's going to give you all these metrics. What is the minimum value? What is the maximum value? First quadrant, third quadrant, median, mean. Simple as this. All this 6 element is given to you if it is numeric. If it is category, basically like a character data type, look at it here, species, it just gives Setosa having 50, versicolor is 50, and Virginica is 50. What does this mean is number of observations associated for this character type. Okay, we have Setosa as one data type, maybe like character type, sorry, not data type, one character type. Similarly, versicolor as the next character type, the Virginica is the third one. So the distinct number of possibilities are just 3. With each distinct property, we have 50 instances, observations. What if we have 1000 observations? Then all 3 will sum up to 1000. Since we have 150 observation, all 3 sums up to 100. And guys, this is the toy data. Don't expect to always have a equal proportion as like here 50, 50, 50. This is a toy data. Okay, you'll be having like 90 observation in one category sometime, and then the other 2 will have just 5 each. Might be possible. Okay, so this is basically data frame under this idea, the species data type. Now the question comes in: how come it handles this? In the previous workshop, we discussed one data type, remember, called factor. That is exactly how data frames are used. Let me put it this way: class of, okay, iris is the data type, data frame. Remember, in previous data structures like list or a vector or basically a matrix, we used squared brackets in order to slice the information, right? Even maybe this one in data frame, we can use squared brackets in order to slice the information. But if you wanted to choose a specific column, I repeat, if you wanted to choose a one specific column at a time, you can use dollar symbol. Okay, dollar simple length width whatever, and then you can choose the column. I choose species. Now look at it here. This is the only data that I open, and then I ask what is the class of it, what is the data type of this specific column. Look at it here. It mentions factor. Remember, last week we discussed what a data type factor is. This is it basically. This is an example of it. A character data type, but it is basically categorized. That we call it as a factor. Simple as that. So with this is the data frame idea. Now the question comes in. Let's see some examples to slice it. Basically like subset it. Iris, a data frame, and then I just perform 1:5, row 1 to row 5, or basically let's put it like 5th row to 10th row. Okay, 6 rows. Comma, then you can specify, maybe we can specify the number of columns that we wanted to get. Let me choose 3:5 because we have column 3 to column 5. Okay, we have maximum of 5, so I choose 3 to 5. Let me execute this. Look at it here. The index 5, it starts with that. Index 10 is the last index. So rows is 5 to 10 row. Okay, row index 5 to row index 10. Column is third column to fifth column. Petal length, petal width, species is basically the 3 columns. So I choose all those. Once we are done with this, basically like this is how we directly subset the elements in data frame. If you directly wanted to choose just one column, as I mentioned earlier, iris, basically a data frame name, dollar, you mention the column name that you wanted to get it. I choose one, I give enter, I get the entire column values. If I choose the other column, I get the other value. Simple as this. Sorry. Yeah, if I choose the other column, I get the other column value. Simple as that. This is how you slice or specifically get the column value. Maybe if you don't want it to here, as like here, I don't want it to use all the columns. I just wanted to specifically just take the column rather than slicing with rows. Yeah, what you can do is rather than mentioning the row property, just give a comma and then go with the column property, so that R can understand that there is no slicing required for row. There is only slicing required for column. The subset is only for column. So let me execute this. Look at it here. We just get to see the 3 column property rather than the row property. Simple as that. What if I wanted to choose the number of rows like 1 to 10 rows, and then the column I choose like the specific value. Maybe like, let's do the reverse now. I don't want to choose the column property. I just wanted to get the row property. I just give comma and then execute. I just get the rows. But it's not always necessary that you have to give a comma. Look at it here. It just says that error in a data frame iris, undefined column selected. Simple as that. So as I mentioned, you have to give the comma in order to understand it. But few places where you planning to change the data type, at that point of time, you might not necessarily need to declare the comma, basically, so that it can understand directly it is rows, just to give the row element. Let me do this one. Look at it here. I just give 1, it directly goes to the column 1. Rest all the values are basically ignored. Sorry. I give iris of 1, it just takes the first column, rest all the values are gone. Simple as that. So this is it, guys, a basic idea of how do we handle data frames and what a data type, data structure it is actually for. Okay, perfect. So with this, we can move to the other data manipulation techniques using dplyr, or basically we can use it with the other properties like basically tdlyr, or what's the other function that I've been mentioning for? Yeah, dplyr, or basically Tidyverse. We can use either of that in order to understand how we can perform the other manipulation activities using any of those data structures. But in order to understand those manipulation, we have to know what a data structure is supposed to. That's why we just discussed the data structures. And guys, there are other few data structures, but this data structures is fair in order to get into the data manipulation process. Okay. So yeah, for one row, okay, in order to perform, like, how do we get that one row property? I just give a comma. Simple. So if you mention the comma, R can understand that, okay, fine, this is it, the slice that we have to perform for row, and then the column, it just works that way. Okay, cool. So this is data frame, guys. Let's start with our next part, data manipulation. What type of other data manipulations, or basically the how we can handle these data structures with using other packages? Data manipulations. Okay, let's start with dplyr. Okay, one and most commonly used package for data manipulations. There are other packages, but dplyr and Tidyverse are most commonly used one. So we are going to discuss dplyr, Tidyverse. This is the two packages that we are going to discuss. And when I talk about packages, since we have seen what is a function and then how it works, but ideally, what is this package? How come R works in a package? Is it similar to Python? Exactly, it's very much similar to Python. The hierarchy goes in like one library can have multiple class. One class can have multiple functions. To put it in the reverse way, many functions can be there in one class. Many classes can be there in one library. Many library can be there in one package. Simple as that. So that's a hierarchy. Okay. So the reverse is not possible. Okay. So this is how it starts with. So we are going to discuss about these two specific packages. Now, there would be dependencies and other stuff. So if you wanted to start with how we get into dplyr or something, for the persons who have not yet installed it, install dot packages. Okay, so this is the predefined function, base function to install the package. Maybe you can use the tool to install it, but it's not always recommended to do it in using the tool. You can use it with this function, install dot packages. Then you can mention what package that you wanted to install. Look at it, what I'm doing. dplyr. Okay, when I mention dplyr, look at it here. By default, R recommended me we wanted to install any of these three packages. With the text that I've given, this is the three that is available for. I give dplyr. Since I've already been installed these packages, I will be getting a notification that the package is already been installed. But if you guys haven't been installed this packages earlier, it might take a few minutes for you guys to install it. So I'm not installing right now because I have already installed, but this code will just do the work. Okay, sorry, I just comment it out. Then this is the way you install the package. Okay, now the question comes in. Okay, I install the package. Is that a one-time work or a multiple time? I have to keep doing it every time. Installing packages is a one-time go. Okay, once you install the packages, until unless it's getting updated, it's not necessary that you have to install it again. Okay, then what is the next procedure? Once I install it, how do I use it? Yeah, using it, whenever you wanted to call it, you have to use library function. Okay, library of dplyr. Okay, the package name, whatever, you just give that, so that if I execute this one, library of dplyr, it says that, hey, R, I wanted to use this package. Can you import this package from my local system? Simple as that. That is the instruction that is given by library. I call it. Look at it here. It just says library of dplyr attaching package dplyr. Okay. Then this is the object that has been initiated, and then it got, what is that, loaded in the environment. If you wanted to see that in a straightforward manner, that comes with, yeah, look at it, guys. dplyr is basically check mark, which means that I have just installed the, maybe called the package in the environment. Simple as that. Yeah, grammar of data manipulation. Simple as that. So that's the title of the package. Think about it, how much it is important for data manipulation, dplyr. So with this dplyr, we can perform all the basic data manipulation that we need to do. Okay, so basically, like, we can perform any operation that we wanted to perform with this package, any data manipulation thing. Okay, to start with, we have a selected list of functions in order to do with dplyr. Okay, so what I am doing is, let's have we have data, right? Yeah, we have iris. So I'm going to use iris data in order to do some examples. Now the question comes in, we have performed data subsets. How do we slice it, and then how do we subset it? Now, apart from how do we use it rather than slice it, is there any other data manipulation functions that can support a better sampling or something? So let's start with that specific package, select. Maybe with this package, select. Look at it, guys. R works this way. I gave a characters. The suggested keyword is select dplyr. So always remember that you choose the right package function, because the same function might be available in many packages. So the operations that it undergo will be different according to packages. Simple as that. So I choose select dplyr. With this, I have to choose what data that I have to go with. I choose iris is the data that I wanted to go with. Then I can choose either all the columns or just leave this. Maybe let's perform this. Select iris. Okay. Look at it. It says data frame with 0 columns and 150 rows. Really? No. Because I didn't mention which column that I have to go with. So I'm choosing maybe specific columns. Let's take, I manually give, what's the data frame? Iris, right? Iris dollar simple width, iris simple length. Okay. Now look at it here. I just give, maybe let's perform with 3 columns. Iris $3. Yeah. So I choose, this is the data frame that I wanted to choose. Then this is the 3 columns that I want to go with. I want to select with. If I execute this, Look at it here. Oh, subset must be a valid. Okay, I didn't mention a vector. Okay. Now what I mean to say is, so what's the error that it says is must subset columns with a valid subscript vector. So rather than describing the table name, okay, we can just mention the column names that should just do the work. Look at it here. So I get to see all the 150 rows. Got it? All the 150 rows, this execution, maybe I'll just put it this way. This is my execution. Select is the function from dplyr. I choose the specific columns manually and then I just get it. Simple as this. This is the purpose of this select function. The question comes in, what it does, it just shortlists few columns. I can perform it with the slicing. Then why do we wanted to use a select function? How come it just being different with the other? Yeah, the idea is by default, this select function will be loading the index of it. Basically, like what we can perform is we can just save it to the specific value. Let's take like a short listed column. Okay, short listed column, I just store it. Okay, so this is the variable that I store it. Now look at it here. Short listed column is having 150 rows and three columns, three variables. With this three variables, what I can perform is, let's take this is shortlisted one, right? Head of, okay, head function. So basically head function does in a way like what you wanted to take from, maybe like just a sample data or something. So I have chosen shortlisted columns, comma, how many number of rows or a sample that I wanted to receive for. I choose 5. So I will be getting whatever the shortlisted data, I choose the 5 rows of it. Look at it here. 5 rows. First 5 rows is basically extracted. This is basically the head function does for us. Okay. With this, the question comes in. Okay, fine. If this is the case, we just performed a simple select and then we shortlisted what we wanted to have. Then we just performed an head. So if this is the way that we started, how we can take it forward, how we can perform the other level of data processing. Okay, is that like mandate that we have to mention the data, maybe like column names this way? We can even use the slicing method in a way like you can use the column numbers or index positions of it so that we can perform the data. Let me perform some more example. Select a function, select dplyr, then I choose iris, my data, then I choose 3:5. Look at it, the same operation. Now I perform head of this with 5 rows. I just get that. Okay, simple as this. So this is how we can understand what we wanted to actually see based on the select. So select is basically a basic function in order to understand how we can just slice the data. Simple as that. Rather than manually doing it, if you wanted to use a function, this is how the dplyr supports it. Then the next function, filter, the next important one, filter function. Question comes in, is that this select function is so much important in that case? Select, maybe select is the one function. But yeah, coming back to this question, how come this can be so important? It's just a slicing property. How come this can be so important? Think about it. Any data that we receive, we are not going to directly start analyzing until unless we shortlist some part of data, because the entire data in real time would be huge. This one, maybe this example that you're discussing here is just like 150 rows. You might be having a 15 million rows. Okay, who knows? We can't load all 15 million rows to have a look at the data, how the data looks like. Okay, so we are going to slice that to just limited number of rows, then we are going to use it. That is the reason we use select function. So that's the reason why we started with that. Okay, now yeah, I got a question. Can we use a range function in this? Of course you can use range function in this. As we have discussed earlier, we just give range of 1 to 5 or whatever the value that you wanted to call with. You can use that one, and then instead of direct numbers, you can use anything. That's basically the idea of using subqueries. Of course you can do that. Okay, yeah, coming back here to the next one, filter function. So this one, the filter function, is nothing that again, it's a self-explanatory. So the difference that it brings with select and filter is that even select is basically sort of filter, right? Then how come this filter means filter? The difference is that Select performs a shortlisted data, basically a subset of the data, not a direct filtered subset. It is basically a subset of the direct data. Okay, but filter can go into the column level property. Okay, it's basically a row. Select works like row and column level property. Select this row, select that column, simple as that. But when it comes to filter, filter can work with column level property. What is that column level property? Is that, let's perform some example. So we have seen, maybe let's perform a summary again so you can see that. Summary of iris. Okay, so look at it. We have species, right? This species column, we have setosa, versicolor, or something. What I'm going to do, as I mentioned, filter can get into column level property. So with this column, I'm going to use setosa as a property. So as a filter itself, a function from, look at it here, dplyr, I'm just choosing it from this package. Then I mention what data frame that I wanted to go with, iris data frame. This is the one I wanted to filter with. But even then, filtering that, I wanted to see, okay, I'm repeating, I wanted to see this specific species. Okay, species is equal to, I'm repeating, species is equal to, maybe equal to, rather than a assignment operator. Remember in the last session, 1 equal to is an assignment operator, 2 equal to is basically a logical operator. Okay, species equal to, I declare setosa. Okay, filter this data frame according to this columns, this property, simple as that. This is where it makes a difference between a select function and the filter function. Let me execute this. With the error code input 1 filter species equal to red. Why? Okay. So it shouldn't be making the difference. Okay, last error to see where the error occurred. Now it says species equal to, is it like column is capital S? Oh my god, yeah, my bad, sorry. Look at it, guys. So as I mentioned in last time, it's case sensitive. Okay, S is basically uppercase. Okay, so filter, I just execute. Now look at it here, we have only 50 observations. Got it? It's not even 150. Maybe let me update. Look at it here, we just get to see 50 rows, not 150 rows. It's the same iris table, iris data frame. Is this the setosa? Look at it, all the species is this setosa. Simple as this. This is how you filter a specific column level property in R. Filter function does that for you. Okay, so this is the second one. Now the next one is like copying data frame. Let's see that. Okay, how do we copy it? Okay, just to give you a, maybe to write it down, filter can perform column level maybe subsets. It's basically, end of the day, it's everything is a subset, but ideally how much the possibility of subset it can be achieving for. Select can achieve with a row and column property within row or a column property. But here filter works with a drill down. The granular level of data can be filtered out. The subset can be extracted with filter. Moving to the next one, most important one, mutate, which is basically, we can call it as a copy, but technically not copy, which almost is a copy. Let me explain it. Okay, when I say mutate, it's a self-explanatory. Think about it. Mutate, what it means, we are going to replicate the existing one. It's basically mutating, but which has been a bit improvised from the previous version, or basically the previous version we extract it and then we just create something else. Okay, so let's perform this way. Let me execute some example. Mutate, the function itself is a mutate function. Now I just wanted to mention let's some operations. Okay, we have 4 columns. Perfect. So we have 4 numeric columns. Okay, sepal length, sepal width, petal length, petal width. Now what I wanted to do, I wanted to add sepal length and petal length together so that I can put length as one column. Okay, from iris table, I wanted to create one column rather than having two different columns, sepal length, petal length. Two different lengths are there. I wanted to make it as one length. Okay. So which data frame that we wanted to use? Iris. So we mentioned that data frame name. Then we perform which column that we wanted to perform with. So what I mean here is that like how much the execution that we wanted to perform. So what I'm doing, length, maybe let me put it a different name, sepal length, petal length. So SP length. Okay, this is the column that I'm creating. Look at it closely. SP length is the column that I am creating. Okay, SP length. I mentioned here, let's perform a simple example like what is this? Sepal length, right? I declare the column names sepal dot length. Okay, plus a simple addition. Okay, a simple addition. Maybe you can perform any operation. I'm just doing a toy example. Okay, so here sepal length plus petal dot length. Okay, now look at it. Let me execute and see if that executes properly. Sepal length is not found. LNGTH. Okay, there is some characters. It's not matching. Petal length. Okay, because basically I'm not calling it with a data frame name, it won't work here. That's fine. Yeah. So here, let me execute this. Mutate column data frame name, comma. What is the operation that you wanted to perform? What is the column name that you wanted to go with? Look at it here. As soon as I execute it, I got created with a new column called SP length. Okay, remember mutate is basically you can just give the direct existing column, direct copy you can perform, or you can perform a direct operations on the existing columns. So you can create a new column based on the existing column, or you can directly copy it. How do we copy it here? What if I don't mention an operation here? I just mention this one, then it's direct copy, right? Simple as that. That's how we can just perform it. So this one, we call it as a mutate function. The question comes in, so where do we use it? Think about it whenever you wanted to perform any operation. Think about it. In real time, the data would be so messy. So what we will be doing is we will be always process the existing data. Then we perform our own operations. That is where the mutate comes into play. In order to perform that, we can either use direct mutate in order to copy or keep a backup of the raw data, or basically you can use a copy function itself. But ideally mutate is the most commonly used one. Okay. Now, similarly, you can perform for sepal width. Yeah, you can perform with sepal width or any of the other functions. Okay. This is mutate, guys. Straightforward one. Okay. So we are creating a new column based on the existing column. That is basically mutate. Okay. Now, with this, we can perform other functions like exactly. This is something that aggregated level, maybe I will put it in a common terms, groups. Okay, group by. Okay, when I say group by, I believe many of you guys could have already been seen Excel or any group by functionalities in piece of codes like Tableau or something. This is no difference with that. Okay, but for the persons who have no idea about what a group by is that think about it. We have maybe here this example. Let me show you the summary. Look at it here. We have Setosa, versicolor virginica. 3 different species is available for us. 150 rows. What? How come this just get to know Setosa has 50 rows and versicolor has 50 rows? This is basically grouped by species column. Simple as that. So what's an idea of number of rows? Simple as that. This is the operation that species we received with. But what if we have, okay, what if we have, rather than just grouping it with this values, what if we just group it with species, but the result that we wanted to see is petal width or petal length. And for the persons who have used Excel, it's almost equivalent to a pivot tables. Simple as that. Not much of a difference. But how do we do it? Let's see some example. Okay, which comes with dplyr function, maybe package. Okay, so okay, group by. Look at it here. Group by is a function that I'm using with dplyr. Okay, So look at it, as soon as I gave that, it just asked me what is the data and then how do you want it to group by. Let me show it because it needs parameter for you to understand. We'll go one by one. Yeah, look at it here, group by one or more variables. Okay, so here the first one we have to pass the data. Next one we have to say how do you want it to go for the default group by, or do you want to drop any columns or something. So when we performing it, look at it here. Maybe yeah, let's perform that so you can understand it. So here it's iris. Okay, then I mention how do I want it to perform the groups with iris column species. I wanted to connect with species. I wanted to make a group by with. Now look at closely. How come this works here? So when I group it, okay, according to what is the species column, it just says that the groups that we have been got is basically three groups. Okay, three groups. With these three groups, the values Setosa starts with. Then we have the other one. So basically the 10 rows is basically the index that we have been received for. Okay. So here we have been performed with simple and yeah, perfect. Yeah. After Setosa, look at it here. Iris species is what the column that you have chosen to perform a group by with. As soon as I perform a simple group by, okay, it just gives the result according to species. As it mentioned that there is three different groups. First group starts with Setosa. The next group will go for, maybe we can view this so you can see the idea how it been executed. Look at it here. Species, okay, the group by property, it just groups with Setosa. Okay, then it goes with versicolor, then it goes with virginica. The idea is the data is actually grouped. Okay, since we already have the data in that specific level, it is not directly been aggregated. Okay, how come we can aggregate with? Maybe let's perform this way. Maybe let it be. Okay, now after I mention what the data that I wanted to get with, after I get the data of how it has to perform with, I mention the summarizing property. Okay, so let's take, I choose the properties here. Okay, you can always, what you can perform is basically like once you get into the function, you can always get to see what are the properties that you wanted to apply for. Okay, first thing data, then how do you want it to add with. When false, the default group by override existing groups. Okay, drop, we just drop it. Okay, dot is basically like variables computing or ungrouping it, which one that you wanted to group with, which one that you wanted to ungroup with. Simple as that. So here the example that you've seen is basically like we discussed, this is the data frame and this is basically the columns that we wanted to group with. In order to perform that, we just have three columns, maybe three distinct values, so that we get to see three different groups are basically created. Simple as that. It's a straightforward one, guys. Okay, so this is basically group by. Then as I mentioned, this is something that you can perform in general. Then you can perform, yeah, the next important thing that you can perform in R is basically merge. So then idea, so what is the difference between a group by and merge? I repeat, group by is something that equivalent to an aggregation. It's basically like summarizing your existing table to distinct properties that you wanted to achieve with. But merge is basically very much equivalent to joins. Okay, if you perform a SQL joins, maybe I'll just write it here. Maybe joins from SQL. Maybe I will just mention from SQL. Okay, just for reference, I mentioned from SQL, but ideally, technically, it's the same joins. Okay, so remember, merge has four functionality. Since we are not directly getting into getting deeper to that, but ideally, like what you can perform is, maybe let me show you an idea. Merge, sorry, look at it here. Base function has maybe like merge is basically from base package, not a dplyr function. Okay, now the idea is if you wanted to perform, maybe let me give you that. Maybe let me show you the list of parameters. Okay, look at it. We have to pass two different data sets, x comma y. You merge it, then you decide which method that you wanted to go for. The first two parameters, you decide what all are the properties that you wanted to go with, basically like the data frames that you wanted to merge with. Once you define what is the data frames, then you can perform this one, the different join types. Okay. So when we say different join types, by default, it just goes with inner join. Okay. It's not necessary, guys. It's what is that? It should be of specific inner join or something, but by default, it goes with inner join. Okay. So here, yeah, here, look at it here. You merge two different data frames by which column? Okay, by which column in column table 1, and by which one in the second column name, second table, what name? The common column. Okay, once you mention this, maybe since we are just using one data frame here, it's not necessary that you have to perform in the same table. But if you're performing with a different table, table 1, table 2, table 1 common name, common column name, table 2 common column name, simple as that. This will just perform you the join, the inner join for you, simple as that. If you wanted to change the type of it, okay, rather than having an inner join, you can, if you wanted to change the type, you will be having the parameter called join type. Okay, join underscore type, that's the previous one. Yeah, maybe like if you just mention that way, it just performs a direct inner join. Okay, if in case if you wanted to use a different one, you can use a different methods, straightforward. Okay, but merge is a straightforward function which we can use for performing a SQL joins. Okay, cool guys. So this is the important functions that I wanted to give you an examples with. Then to start with, how a merge is not a direct what is that, dplyr packaged function, but it's from a base function, but it's still very much important to go with. Cool. With this is basically dplyr, guys. Okay, the basic dplyr packages that we have been used with. Okay, now let's discuss with the next one. Okay, let's go with Tidyverse, the next important package for data cleaning. Okay, let me show you. For the persons again, this is Tidyverse. Okay, so if you haven't been installed, I repeat, it's the same process for all the different packages, but you have to make sure that you just give the right insta maybe package name, Tidyverse. Okay, Tidyverse. This is the package, guys. The next and foremost important package for data manipulation. Okay, since I already installed, let me show it in the packages tab. Tidyverse. Yeah, it's here. Look at it here. I have installed it. So let me call it. Now look at closely. It is not checked in because I haven't called the library function. So I call with library Tidyverse. Maybe Tidyverse. What you can do is you can directly even check mark it here so that it will just work for you. Or basically you just execute it here. It just calls you the library of it. Okay. And as the package, whatever the packages that we have, it just calls all the packages. It just got executed, which means now we can actually execute the Tidyverse package. Simple as that. Okay. So this is an idea, guys, in order to start with Tidyverse. Now with this, after Tidyverse, what we can perform here is, let's start with the basic functions of Tidyverse. In order to give you an idea, these functions, the functions that we have discussed, like select, mutate, or filter, these functions are also available in Tidyverse. Okay, it's a similar package, similar function. Maybe let me show you that. Select. Okay, we have many functions listed here. Maybe filter. Okay, cool. Then so maybe we can perform a summarize. Cool, it's still in dplyr. Okay, so since the functions are already there in dplyr, maybe you can use with Tidyverse, but it's not necessary that you have to just use it with Tidyverse. It's the same function very much similar from both the packages. Okay, so you can use this package, the Tidyverse package, in order to give the basic executions. Okay, now with this, let's see some examples. Okay. Um, okay, so with this Tidyverse, let me show you this one, Tidyverse. Okay, so here guys, the Tidyverse package, the list of the properties that we have for Tidyverse is actually very much higher comparing with what is it, dplyr. What I mean to say, Tidyverse is more broad than this one. dplyr is that it performs, okay, the operation which it sometimes can't be done with dplyr. Why do I want to say this can't be done with many places? Why it can be done with Tidyverse? Why not with dplyr? Is that it's about the package properties, and then as I told earlier, this is basically like what is this? The properties of Tidyverse or dplyr are generally generated with or contributed to community by any individuals as like you and me. Okay, since the usage of any of these packages are basically introduced by different persons in order to have an idea about a different functionalities. If the function might be available, the same function might be available in what is this, dplyr, but it's not necessary that we have to limit with that specific function. Simple as that. Okay, so this or then Tidyverse has also has similar functionalities where it can just perform, as I mentioned, like a filter or something. You can just filter, select, mutate. All these functions can be done with this one. Okay, so we can use that. Then let's see some examples with this. So here, I believe you guys could able to see the screen now. Yeah, here. Let's start here. The first one to go with is basically we can call it as a pipe symbol. Okay, I repeat, the first thing that we can go with Tidyverse is basically you can go with pipe symbol. I got a question here. How to execute these functions using SQL instead of dplyr in R? Yeah, exactly. As I mentioned, you can use merge function. That's an exactly the what I mentioned here. What you can perform is you can use a simple merge function and then define, because I just have one data frame, I'm not performing it, but I really like if you wanted to perform it, iris table one, iris, I give the same table for a time being. Okay, then I just mention what type that I wanted to connect with. Okay, so look at it here, I just wanted to see mention the column names. If the column names are common, I can mention what column names that I wanted to do, maybe basically just by. If it is by x, I mean to say iris, basically a dollar, which column that I wanted to connect with. Okay, you can use species or basically you can use any of the other columns, common column. Okay, so I just give maybe petal width is not appropriate, so I just choose species. Then I go with the next parameter by y. Okay, here I mention again iris dollar species. Since this is the same data frame, it's not going to make much sense as I mentioned earlier. So what you can perform is you would just you have after mentioned it, what you can do is you can just mention this properties x and y we already mentioned. Sorry, yeah, we already mentioned x and y. So my left table is x, my right table is y. Then the join that I wanted to perform on my left table is basically by dot x, and then the right table is by dot y. Since this data is the same data, if I execute this, uniquely valid column, sorry, since I didn't mention this way, so object species not found x. Yeah, we have the data, but species by dot x by y. Why is this a small cap? Okay, so here species is not found. It's the same data frame, but ideally just because of some property here, it just throws an error. But ideally, guys, it should just work in if the declaration is just right. Okay, since I'm just using the same data frame, I really doubt how come it would work. Okay, maybe I will just put it for iris 3. Okay, some data is basically not connecting. Okay, there is no iris 3. Okay, in iris 3 we don't have the species column, so I just mentioned that. I just mentioned by rather than having two different columns because it's the same column name. Oops. Cool. Here by default, I just told to merge it so that it just connected it. But look at it here. I told merge X and Y, two different table, and then I just mentioned didn't give any properties like because there should be some spell or case sensitivity comes into play. Okay, instead of declaring that way, if you perform it this way directly, because it just has the same column name, by default it just understands species is the common column and then it just connects the value so that we get to see the appropriate value of all the observations. Simple as that. Now look at it here. Once it just got connected, the property has been actually increased. Look at it here. We have 152 rows, but it's not technically it should be. Okay, since the data is the same data, it just has some discrepancies over there. But ideally, I would not recommend you to do this way because if you have two different data frames, just try to merge with data frame 1 and data frame 2. That will just gives you a perfect join types. Simple as that. Okay, that's a straightforward thing, guys. Okay, now to go with, as I mentioned, yeah, coming back to this one, the Tidyverse, there are few, it's not much of a difference, many, but ideally few things which is not directly available in other things. Okay, so when we talk about the pipe, okay, the symbol, maybe to give you an idea, percentage greater than percentage. Okay, this one we call it as a pipe symbol. Okay, which is actually a commonly used feature in Tidyverse. Then we think about it like why can't we use it in the other packages? Why we use it in Tidyverse? Because this is basically defined and works very much pretty well with Tidyverse rather than dplyr. Simple as that. That is the reason why we use this pipe symbol in Tidyverse, not in what is that dplyr or some way. Okay. Then what it does is actually is let's perform a simple example. Okay. So I'm going to perform. Let's give a number. Okay. Let me comment it out. Let's give a number. Let's take x equal to 10. Okay. I give a number x equal to 10. As soon as I give this, how do we perform this? Well, let's do some examples. Let's take some operations. I perform square root. Okay, I think I do have x. Okay, so square root of 10. Object is not defined. So let's call base function. Yeah. So square root of, oh, I didn't call the x. I'm sorry. Yeah. So this is the square root of x. So you just perform the simple operation, right? Now think about it. This pipe function comes in handy at some places. Okay, some places we can't directly use the operator, the other operators, because that operator might be, okay, it's not always, but might be having some, what is that, operational issues where that has been used with different combination. Let's take you apply a simple multiplication operator towards with a division or some other operations. Okay, so what happens is that that operator might be decisive with adding with the other operator. Some places maybe there are scenarios that happens that way. This pipe symbol comes in handy at such situations. Okay, let's perform that. Now think about it. X is the data variable that we already have. With this data variable, what I perform is percentage, sorry, yeah, x percentage greater than percentage. Look at it closely. I perform the same pipe symbol. With this, I just perform square root. Now look at it here. I performed square root of x, and this is almost the same. Let me execute this. Look at it here. How come a square root of x performed this, and the this pipe symbol and then the square root also performs the same. What's actually doing this? What is this is actually doing is it just assigns, okay, it just assigns this function to be performed on this variable. Simple as that. This is what the pipe symbol is actually doing. Okay, it is basically a symbol which is placed in between the value on the left and then the function on the right. Okay, so this pipe symbol simply takes the value to the left and passes that value to the maybe function that we are defining on the right side. Simple as that. This is basically the pipe function, which is actually comes in handy when we use Tidyverse. Simple as that. Okay, so this is one of an important thing that we can use it, guys. Okay, apart from this, maybe like as I mentioned, like you can use the filter from dplyr function, or maybe basically the other functions can be used, mutate or summarize or grouping. You can perform it that way. Okay, now the question comes in, is that something that we can use in order to summarize also? Basically, like we have discussed, maybe I mentioned group by, right? Okay, fine. With this pipe function, can we perform a group by operation? Yeah, let's see some example. Okay, so let me start with we have iris data, right? So what I'm going to perform is I'm going to perform iris data. Okay, this is the iris data that I'm taking. Again, I define the pipe symbol. As I mentioned, whatever the function that we're going to give on the right side is going to apply on the data on the left side. Simple as that. With this, okay, the pipe symbol, then I mentioned, let's start with group by. Okay, group by is the function that I'm taking with dplyr. Okay, keep this in mind, pipe function, and then I just use a dplyr function from the group by. Then I'm just going to support with this iris data. So as I mentioned, let's perform with group by species. Okay, the species is basically used here. Yeah, capital yes. Okay, group by species, and then the on top of the iris data. This is what we are just mentioning the functions for. Now think about it. As we mentioned about this way, let's execute this. Maybe let me put it in the same line so you can understand it. Now look at it here. The same group by operation has been performed here. The species is 3 groups. It mentioned a species is 3 groups. Once we have the 3 groups, each group has its own property. Setosa or versicolor or virginica has been grouped accordingly. Simple as this. So this group by function has been performed on iris dataset, straightforward, simple as that. We just mention how or which column that it has to perform a group by with, simple as that. Once we have this property, so we have mentioned how to group it, and then like how it can perform a simple pipe function in order to perform it. Then after getting this property, okay, the question comes in, is there any other direct function we can apply with this one, maybe merge or something? I think like, yeah, this should work for merge, for joining, and then a simple tidy was the pipe function, and then the how we can apply this pipe function in a dplyr package function based functions. Okay, so yeah guys, this is a basic idea about how we can perform a simple what is the Tidyverse and dplyr functions in order to perform any data manipulations. Okay, so let's have a quick recap of what are the functionalities and then the data structures that we have discussed so far, so that you can have a clarity on what we had today. Okay, so here let's have a quick recap. To start with, we have started with data structures. So the data structures started with vectors, right? So the first data structure that we have started with vector, as I mentioned, it is a one data type and then a one dimensional data structure. Vector can't be of 2 data structure. It is of just one data structure. Simple as that. It can't be having 2 different data structures, maybe 2 different dimensions. Then we have seen that as a disadvantage, and then we moved to resolve that disadvantage. Rather than having one dimension, is there a possible that we can move to 2 dimension? Then we have matrix. So the matrix is basically a 2-dimensional data structure, but it can consist of only one data type. This is the differences. Then we have moved to list. How come we can solve this problem? So we have solved that specific problem of having one data type, not supporting just one data type. We have moved to list, considering that list is a multi-dimensional, maybe like it's not just one dimensional, it is not about like one data type. It can consist of multiple data types within one variable, that is list. But that comes with the disadvantage that list is one dimensional rather than having multiple dimensional. So we need some data structure to support two dimension and multiple data types itself. That is where we got to see data frames, simple as that. So a data frame is two dimension, which has rows and column property, which can support multiple data types. But one column can have only one data type. It can't have two different data types, simple as that. And here, the next one, we have, then we started to discuss about dplyr and what is this? Yeah, Tidyverse, two different packages. To start with, as I mentioned, dplyr is a grammar of data manipulation in R. So, which is the most important data manipulation package which is available in R. So we started with that. With that property, we have seen some examples of how come we can select the data, how come we can shortlist the top specific head data or a summary function. Then we moved to filter function. The difference between a select function and then the filter function is select function is something that where we can choose what is the number of rows and what is the number of columns that we can discuss about, have a subset about. But filter function is basically that it performs a subset, but at the same time, it can go granular in a way like having a column level subsets that way. So that's the basic difference between select and filter. Summary performs if it is a numeric value, it just gives you the minimum, maximum, first quadrant, second quadrant, median and third quadrant and mean value together. If it is a factor level data type, then it's going to give you the number of rows that is present with a specific category, simple as that. Then we have moved to mutate function. Mutate is very much similar to copy function, but mutate is something that which we help to perform or generate new columns based on the existing columns, simple as that. That is mutate. Then we have performed a group by function. So how we can group by different or maybe the category level, the factor level data into a subsets, basically like having a sort of pivot table or a simple, what is that, group by functionality that we perform in SQL. Then we perform a join. Join is very much equivalent to merge is basically equivalent to a join in general SQL. So in order to talk about it, we can always try to have a different joins, inner, outer, left and right. So when we wanted to perform a join, yeah, I get a similar question for this in a way like, how can we get to see that? Okay, it's basically that I just declare one data iris and then the second data is also iris. This is where I told that like, since if you have two different data frames, then you can perform a direct join where it can associate with the specific common column. What you can do after this, you can just mention by is equal to which column that you wanted to mention as a common column. So which column will be acting as a common column between both of the table. You can mention which specific column in order to perform the, what is this? Maybe I'm just mentioning species, so that it will perform a simple join based on this specific values, iris, x table, y table, and then the species column of it. Basically the simple join property, the common column for. If in case your column name is different in both the tables, by.x means to have what is the column name, the common column name from x table, and similarly by.y mentions that what is the common column name from the second table, simple as that. If we have this property, then it will just perform a simple. Look at it, guys. I just executed it. It just gave me, it just gave me altogether of 11 rows, but it omits 7,389 rows because of species is a common column, right? So one row will be giving me another 50 joins, inner join, right? So what happens then? 50 into 50, 2,500. Similarly, we have three rows, basically like three distinct values, Setosa, versicolor, and Virginica. So what happens then? It becomes 2,500, 2,500, 2,500, approximately 7,500 observations. Since we already have triple one observations here, we have 7,389 here, which is basically 7,500 observations, performing a simple inner join. Simple as this, guys. So this is basically a merge function. Okay. I hope this answers the one you just asked for. Okay. Then Tidyverse. Okay, so let me go through your question. Execute function SQL. Then duplicate show most function. Yeah, I believe, yeah, you got it, that one. Perfect. And then we moved to Tidyverse. With Tidyverse, I've told that this is the most important pipe function that we use in Tidyverse, which is not actually generally used with dplyr, but when it comes to Tidyverse, this is the most commonly used one. So we have a variable, we have a function to perform. But if we wanted to perform with this one pipe function, we just assign the variable on the left, assign the function on the right. Then whatever the value that you have on the left will be assigned to the function on the right side, and then the execution happens accordingly. This is basically Tidyverse pipe function, simple as that. Similarly, we just performed a cross combination of one Tidyverse and then the one, what is this, dplyr function. So in order to have that iris data set performing a group by on top of the pipe function. So pipe function helps us to perform a group by on species using an iris data set, simple as that. This is basically Tidyverse answer. Okay, perfect guys. So yeah, this is basically from my side for today for data manipulation using R. Okay, I hope you guys enjoyed the session. So if you like the session, click the like button, subscribe to the channel, and see the video again. And if you couldn't able to get some specific topic, don't forget, maybe like feel free to comment it out. We are up for any clarifications. Okay, cool guys, thank you so much, have a nice day.
Thank you so much, sir, for the informative session. Dear students, that was about the session third of the art programming. So next Sunday we'll be coming with the fourth session of the art programming. So stay tuned with us. This will be continued till the fifth session. It will be back to back in the same flow. We have shared the feedback form in the live chat. Please do fill that form as well. And apart from that, if you are a college student, yes, if you are a college student, we have an announcement for you. Currently, we are hiring campus ambassadors from the various colleges across the pan India. So, like, if you are a kind of a community lover and you want to build a good community and the learning culture in your college, then this opportunity is for you. So, take the benefit of it. I have shared the link in the chat. You can visit there. It will be a small process. Apply, shortlisting would be there. Just apply the shortlisting, interview, and onboarding of the campus ambassador. So thank you once again for being a lovely audience, and thank you so much, sir, for connecting with us today.